Okay, so in this section, we are going to basically talk about, again, roots and zeros of polynomials, just kind of, tie a couple of things together. Let's do some vocabulary review. Take a look at this function. This is, p of x, x to the 4, blah, blah, blah. So you see the degree of this function is 4, right? And so the zeros of the function are -3, -2, 1, and 2, right? Clearly. The roots are also the same things, okay? So since, -3 is a root or a zero, then x plus 3 is a factor of this polynomial. X plus 2 is a factor because -2 is a zero. 1 is a zero, so x minus 1 is a factor. 2 is a zero, so x minus 2 is a factor, right? So if we know the zeros, then we can easily come up with the factors of p of x, and those are just x minus each of the zeros or the roots, okay? And then when we talk about the x-intercepts, those are these. So second semester, right, moving on to pre-calculus, whenever we talk about intercepts, x or y intercepts, we're always going to make sure that we write them in coordinate form. All right? Okay.
What's coordinate form?
Like this, like -3, 0 instead of x equals -3. Okay. So take a look here. Solve the equation, state the number and type of roots. Okay, so let's solve this one first. Your go-to, whenever you have any equation, should be, can I factor this? Okay, that's always the simplest way to do it. So here, this is going to be x plus 8, x minus 6. So x equals -8, x equals +6, right? So we solve this. What do we get? How many solutions? We get 2 real solutions. Okay? And they are also rational. All right, so since it asks for roots, let's just say roots. Right, so I get 2 real roots, and they are both rational numbers, right? Okay, so let's take a look at this one. X to the 4 minus 256. So again, I'm going to factor x squared, right? Plus 16 minus 16. So going back to, do we have to know for tomorrow's quiz, or, for the quiz, do we have to know anything from the previous lessons in chapter 5? Well, the way to factor this was technically covered there, right? How to solve this was covered there. So all of these skills are things that you have to bring with you every single time you have an assessment now. All right, so we can factor this further. X squared plus 16 stays, but this will be x plus 4, x minus 4 is equal to 0. So now we need to find the roots from here. For this one, I can't factor it anymore, but I can set this equal to 0. So x squared equals -16. X is plus or minus 4i. From here, I get that x equals 4, x equals -4. Okay? So let's take a look at the number and types of roots. I have 2 complex roots here and 2 real here. So the roots are 2 real and 2 complex.
What does rational mean again?
You should always know what rational means. It's a number that can be written as a fraction, or it has as a decimal. It doesn't. It ends or repeats.
So why is the top one rational?
This one too is rational. If I want to be okay. Okay. So here, let's take a look at this one. All right. So again, go-to should be factoring. So let's factor out the x. And I get x squared minus 6x plus 7. Okay, this doesn't factor anymore, right? So I need to find the roots using the quadratic formula, right? So just for this, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So x is 6 plus or minus the square root of, that's going to be 8 over 2. So 6 plus or minus 2 root 2 over 2. Divide everything by 2. So this is 3 plus or minus root 2. Okay. From here, I get that x is equal to 0. So my roots are x equals 0, x equals 3 plus or minus root 2. So how many total roots do I have? 3 roots. Okay, or sorry, let me write that. 3 real roots, 1 rational, 2 irrational. All right? These are irrational roots. Okay. Here, again, we're going to factor. So this is a difference of cubes now, right? So x minus 2. And then here, I square the first one, plus multiply the 2, plus square the last one. Okay, so from the first one, I get x equals 2. This one, I need to use the quadratic formula again. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2. So x equals negative 2 plus or minus the square root of 4 minus 12 is negative 8. No, 4 minus 16 is negative 12. Over 2. So this is negative 2 plus or minus 2i root 3 over 2. So this is negative 1 plus or minus I root 3. How many solutions did I get? 3. So now I have 3 roots, 1 real, rational, and 2 complex. All right? Okay. Now, how many roots did I get for this last one? 3. What's the degree? 3. How many roots here? 3. What's the degree? 3. How many roots here? 4. And the degree is 4. How many roots here? 2. And the degree is 2. Do you see that? That is not a coincidence. This is a theorem in math that says, listen, this is important. This is a theorem in math that says, whatever the degree of your polynomial is, that's how many roots your polynomial will have. Now, those roots can be, those solutions can be real or imaginary. However, there has to be exactly the same number of solutions as there are degrees, right? As the degree is. Now, how many times does A cross the x-axis? Twice, because it has 2 real zeros. How many times does B cross the x-axis? 2, right? It's a degree of 4, okay? It's a degree of 4. It's got 4 zeros, but it crosses the x-axis only twice, right? So if I were to graph this one, x to the 4 minus 256, right? Let's see. X to the power of 4 minus 256. You see that? It only crosses the x-axis twice. So by looking at this, we're like, oh my God, does it only have 2 zeros? No. Math says it's got to have 4 solutions. It's just that 2 of them are imaginary and the other 2 are intercepts. Okay? Now, another thing. Imaginary solutions, if there are imaginary solutions, they always come in pairs. Okay? So look at this one. 2 complex, not 1 or 3. Okay? Every single time you've got a complex solution, it's got to be in pairs, right? So this one too. This is x to the power of 3. How many times does this cross the x-axis? How many x-intercepts? 3. Because look, it has 3 real roots. So it crosses the x-axis 3 times. 1 at 0, 1 at those numbers. Okay? Nathaniel, do you have a question? So look. You factor this, you have a term here. Every single term needs to be set equal to 0. Okay? All right, so this is really, really important what I'm telling you. So I don't want you guys to be distracted by anything else. What I'm telling you right now is super, super important. Okay? So this one has 3 real roots. It's got to cross the x-axis 3 times. Okay? These are all connected to each other. Okay, so let's talk about the complex conjugates theorem. Remember what I just said. Imaginary numbers or complex numbers come in pairs. You can never have one imaginary solution. You can never have one complex solution. It always has a buddy. So take a look here. You have -1 plus I root 3, -1 minus I root 3. Take a look at this one. You have positive 4i, negative 4i, right? So that means if a plus bi is a 0 of a polynomial, a minus bi is also a 0 of the polynomial, and those two are complex conjugates of each other. So if I have 2 plus 5i, what would be the complex conjugate? 2 minus 5i. And if one is a solution, the other one also is a solution. So take a look here. Write a polynomial of least degree with integer coefficients that has the given zeros. If these are the zeros, then we need to first find the factors, then we need to write the equation for it. Okay? So 2 things here. First, if 2 plus I is a solution, so is 2 minus I. Okay? Now, f of x is equal to, make sure you guys are writing this down. There's a lot, and don't write too big. You take each one and you do x minus that number. So x minus 2, x plus 3. Okay, you've got to change the sign. Now here, x minus the first, x minus the second. Do you see that? Okay, x minus the roots every single time. And in math, we always alternate, like parentheses, brackets, and so on. Okay, so now we have to multiply out this entire thing. Okay, so let's do this. F of x equal to, okay, this you can FOIL. I'm not going to spend too much time on it. X squared plus x minus 6. Okay, now here, okay, there are many ways to do this. One way is this. I'm trying to figure out which way I want to show you guys how to do it. Okay, let's just multiply all this out. Okay, let's distribute the negative. All right, so here we're going to get x minus 2 minus I, x minus 2 plus I. Okay, so this is x squared plus x minus 6. And now we're going to have to multiply this out with each other. All right, so first multiply this x to everything in the second parenthesis. So x squared minus 2x plus ix. Then multiply the -2. -2x plus 4 minus 2i. Then multiply the -i. -xi minus 2i minus I squared. And don't skip too many steps because then you get the negatives wrong.
Is it plus 2i?
Where?
It's negative I times negative 2. Negative ix plus 2.
Oh, here? Here? Yeah, okay. So now we have x squared plus x minus 6. Okay, we have 1x squared minus 2x is minus 4x. Okay, ix and xi, they cancel. Negative 2i, positive 2i cancels. And then I have 4 plus 1, so that's a plus 5. All right? All of the i's should go away because you're coming up with a polynomial, with a real polynomial. And how many times have you had x squared plus ix plus 5? Never. Okay? All of the i's should go away. If they didn't, it's a human error, right? Okay, now you do the same thing, multiply that to that. So let's do that again. X squared first. So I get x to the 4 minus 4x cubed plus 5x squared. Plus x, whoopsies, right, multiply that, and then multiply the negative 6. Right? Okay, and now common terms. So we have x to the 4. Let's see, minus 4x cubed plus x cubed minus 3x cubed. 5x squared minus 6x squared minus x squared. Oh, no. There was also a minus 4x squared, so minus 5x squared. Right? Okay, and then 29x minus 30. So at the end of the day, f of x is this. Okay? Yeah. Okay? So, yeah. Wow is right. Takes a little bit of time, but super cool and satisfying. Yeah.
Is there ever going to be like a shorter way to do this?
No.
This sucks if you made it. If you made it one
There actually is a shorter way, but this isn't that long. Okay?